Shall we start?
Yes, sir. Good morning, everyone, and welcome to this webinar of the CoExist project. This webinar will discuss Earth observation-based monitoring of environmental-related transhumance patterns in support of conflict prevention in the Sahel. So during this webinar, we will be looking at, the speakers will be looking at different tools that have been used in order to support an Earth observation-based monitoring system with the goal of producing suitability maps in an effort to support spatial decision and to better understand environmental suitability for transhumance in order to mitigate conflicts related to transhumance, as well as increase productivity of transhumance activity and thereby promote food security. Today's speakers will include Anne-Catherine Schäfer, who is the Chief of Mission for IOM, the International Organization for Migration in Chad, where the transhumance tracking tool and the Earth observation-based monitoring of transhumance patterns were implemented. Another speaker will also be Maximilian Schwarz. Maximilian Schwarz is a PhD student focusing on environmental related factors that explain the relationships between natural resources and human activities. He has a background in geography and climate and environmental science, and is an expert in large-scale analysis, geospatial modeling, and big data analysis. The third speaker will include Damien Jussel. Damien was coordinator of IOM's Regional Data Hub for Western Central Africa from 2017 to 2022. He took part in the creation of the transhumance tracking tool, one of the key tools being used for the analysis that will be presented today. He is currently working still for IOM with GMDAC, the Global Migration Data Analysis Center. The fourth speaker will be Godela Rosner. Godela Rosner has been head of the Application Development and Data Exploitation in the Earth Observation Department of the German Space Agency at DLR since 2010. Ms. Rosner joined the German Space Agency at DLR in 2005, where she was responsible for land applications and the Scientific Mission Support Program for the NMAP mission. After several years at the German Remote Sensing Center, where she worked in research projects on environmental and landscape monitoring with remote sensing. Ms. Rosner studied physical geography at the universities of Hamburg, Rennes in France, and Bonn, with special emphasis on geoinformatics and remote sensing, and is committing to bring Earth observation data into operational use in science, industry, as well as for political decision-making. And our final speaker today will be Yonas Franke. Jonas Franke has been managing director of Remote Sensing Solutions, a German-based Earth observation company since 2018. Dr. Franke has a PhD in geography and is an enthusiastic environmental monitoring expert. His expertise lies in Earth observation and the development of innovative monitoring practices in a wide range of applications, such as fire management, sustainable agriculture and forestry, public health, or renewable energy production. His focus is to implement these methods into operational practices. So once again, I would like to welcome all attendees to this webinar, which will discuss the CoExist project. But what exactly is the CoExist project? CoExist, as you can see on this slide, is a project that was funded by the German Ministry for Economic Affairs and Energy. It is a project that involves both the International Organization for Migration, Remote Sensing Service, and the German Aerospace Center, or DLR. The CoExist project has combined new technologies, including modern Earth observation capacities, as well as artificial intelligence data analytics and field-based data collection through IOM's transhumance tracking tool, and analyzes the spatial temporal dynamics of transhumance and associated risks of conflict and population displacement. As such, the CoExist project tries to better understand patterns of transhumance through these various technologies that were combined during the project in order to identify potential areas of conflict to help plan effective conflict-sensitive solutions by all actors involved in transhumance management. However, this project also aimed to better understand environmental suitability for transhumance, not only to mitigate transhumance-related conflicts, but also to increase productivity for transhumance, which is one of the key agricultural production systems in West and Central Africa, and thereby promoting food security. During this webinar, speakers will present some of the key aspects of the project, from presenting IOM's transhumance tracking tool, which was used as a field-based data source, through the role of Earth observations, all the way to the developments and outcomes of the CoExist project, as well as its potential implications for program and policy. Very quickly, in terms of today's agenda, we will first look at transhumance in Central Africa. So there will be a general introduction to transhumance in West and Central Africa, as well as an introduction to the transhumance tracking tool, to IOM's TTT tool. We will then look at how Earth observation can promote data-driven approaches. And then we will go further into the CoExist project, looking at how this project has enabled the monitoring of environmental conditions via Earth observations, as well as other new technologies, mapping the environmental suitability for transhumance. And finally, this webinar will delve into policy and programmatic implications of Earth observation systems in the context of transhumance. The presentation will be followed by a question and answer session. So if you have any questions, please feel free to write them in the chat, and speakers of panel members will be happy to respond to any questions you might have at the end of the presentation. If you wish, you can also raise your hand through Teams if you would like to ask your question directly to panel members. We would please like to ask you to refrain from unmuting yourselves during the presentation and to wait until the end of the presentation to all the way to the Q&A session to ask any questions you might have by raising your hand. Or feel free to also write your question in the chat throughout the webinar. After the Q&A sessions, we will have closing remarks as well as outlook to the future of how Earth observation systems can be developed and can be further implemented in the future. So I wish everyone a very successful and very enjoyable webinar. I'm sure participants and attendees will gain a lot from this presentation. And without further ado, I will give the floor to Damien in order to present transhumance in West and Central Africa and introduce the IOM's transhumance tracking tool. Damien, over to you.
Thanks, Ariel. This first section is not going to be very long. I think I don't intend to present really the full dynamics of transhumance in West and Central Africa. That would be way over my my grade. But I think I can give a few remarks and then dive into the transhumance tracking tool or TTT. So as most of you here probably know, the transhumance is this seasonal movement of livestock from one point to another, and usually in search of pasture or of water. And cattle is usually accompanied by herders and from time to time also by their families. Transhumance movements in the regions are generally characterized by cross-border movements or internal movements, what we call grande or petite transhumance, and cyclical movements, usually following like a north to south axis in usually fairly fixed period of time, based on geography and of course on the seasons, whether it's the dry or the wet season. It's quite difficult to estimate the number of individuals involved in transhumance, but FAO was giving figures of about 20 million individuals involved directly in transhumance, which is quite massive. It's also a very important economic activity and as such a driver of regional development. And sorry, transhumance has in the past decade been subject to quite a lot of upheavals with the climate variability, with the demographic pressures, the growing competition over resources that are getting scarcer, insecurity and political vulnerability. And all of these have deeply affected the transhumance routes, the patterns and the flows. And we will discuss this a little bit more in depth with other speakers later. One main kind of corridor is the Central Transhumance Corridor, which links basically the Sahelian countries to coastal countries. We'll show you a map after, and has been quite particularly affected by some of the changes we mentioned just before, resulting in recurrent conflicts between herders and farmers communities, particularly. And the COVID also had the outbreak of COVID also resulted in quite a few restrictions on borders, which led to also restrictions on movement for transhumance herders. So with this in mind, we you can go next slide. We created this tool that we call the transhumance tracking tool, which intends really to provide a bit of a it's a toolbox, like to provide statistical information on transhumance to allow, especially policymakers, but also program colleagues to better work. The approach was then to create a few tools that you can see here: a mapping tool, a counting tool, an early warning one, and an individual survey that responded to some of those specific needs of policymakers or program colleagues working on transhumance. If you go on the map after, you'll see some of the corridors that I mentioned. Those are really schematic ones. They're not really accurate in this specific map. There are too many. But it gives you an idea of how the Sahelian countries and the coastal countries are very much linked by transhumance movements. And some of the TTT are basically taking place in all of those orange framed square. And particularly, I think the one we're going to look at today is the activities that took place in Chad and between Chad and Central Africa and Cameroon on the different corridors that exist there. So to go slightly, but a bit quickly on the tools, I'll focus on the first three: the mapping, the counting, and the early warning. The mapping itself, next slide, is basically something that we used to do within IOM quite a lot as part of what we call the DTM, the displacement tracking matrix. The mapping is kind of the base, like it's our starting point when we get into a location and we want to understand a little bit better the different transhumance dynamics in the region. What we start with is, of course, doing a mapping of the main corridors, of the calendars, of the main infrastructures related to transhumance or to farming as well. And those, of course, never happen ex nihilo. It's always done with the support of the communities, and preferably what we do with IOM is work with a large network of transhumant associations that is called the RBM, Réseau Bilital Maroubé, which does a lot of this work on the ground, especially on data collection with us. So the mapping is going to give you an idea of the structures, as well as as you can see in this sort of heat map, an idea of where the main transhumants on the map are. And this one date from 2020, 2021, where we had done an exercise following COVID to better understand basically what was the impact of COVID in the region, and we found out that a lot of the transhumance herders and their cattle were stranded in Mali, in Niger, because the countries had closed their borders to any type of movement. So the mapping gives us this idea of stocks, basically, of where people are. After that, we also have a counting tool, which if the mapping is giving us a stock, the counting is giving us flows. And this one is also kind of just simply counting movements from on different transhumance axes to have an idea of the sheer quantity of animals and herders that are crossing and of the directions they are taking. So it gives us an idea of the flow itself. And then finally, we have a third tool, which is looking at early warning. And this one is kind of taking hotspots that we identify with the communities or with the support of our civil society colleagues. Hotspots where we know that there are potentiality for conflict between especially farmers and herders. And on those kind of big areas, we work with community relays, basically, people that are going to give us some information whenever you have potentiality for conflict, which means usually whenever you have an early or a late movement of herders, or whenever you have a very heavy number of herders and cattle heading to one space, we usually trigger a certain questionnaire or certain information that goes to our regional focal points in those areas. Here, what really matters, you can see here a result after of this type of early warning. What really matters is not so much the reports that we're going to do at the end, but also the flow of information, and because the information we want to make sure goes back down to the communities and to the municipalities, so that they are aware of this type of risks and if there are ways of preventing those type of conflicts. We try to have this information flow going both ways, basically. I think that I'll stop here. I think what really matters is for you to have a brief idea of how this TTT works, but then then we need to see how this has been included in the Earth observations work done by RSS. So over to RSS colleagues.
Thank you very much, Damien, for this introduction to transhumance in the West and Central Africa region, as well as a presentation of the various tools of the transhumance tracking tool. And I will now give the floor to Godela Rosner, who will provide an introduction to Earth observation systems and how they can support data-driven approaches. Godela Rosner, over to you.
Okay, thank you. And you will forward the slides when I ask you to, is it right?
Yes, absolutely.
Okay, perfect. Yeah, so I wanted to, well, first of all, hello to everybody. I'm very happy to be here and join you. And I also want to bring over the greetings of my colleague Jens Danzeglocke, who some of you might have met during in the course of the project. Unfortunately, he is ill today, so he cannot join, but is is thinking of us and is wishing us a good webinar. To start with, only a few words on the German Space Agency at DLR. It's a federal institution supporting the federal government in planning the space strategy for Germany, and is also representing Germany in the relevant gremia and institutions like the European Space Agency, but also in some committees of the European Union. And on a very practical level, we are also granting contracts, or we're lending grants to research institutions, but also federal authorities and also enterprises to develop new applications and new aspects in the context of space. And in the context of my department, Earth observation, of course, we are focusing on the benefits of Earth observation. So from technology development, mission development, but also to applications and data exploitation. And I come back to that later in my talk. One of the key drivers for Earth observation in these days is the Copernicus Program of the European Union. So it's really a flagship program that has been initiated back in 1998 and now evolved to a real infrastructure of observing capability on the Earth. So to monitor the Earth globally in all its environmental dimensions, also provide information and data relevant for crisis management, for security risks, and also man-made disasters, and to establish some independence in this area. As before we had the Copernicus program, we were relying on American capabilities and others. So now we have this Copernicus program that is providing us with global data, which is fully free and open to everyone. And with that, not only helps the European Union in following up their tasks and duties, but also in the wider context, the whole citizenship and digital economy to grow and develop. So the backbone of this whole program is the fleet of Sentinels that has been established. And all of these, it's a family of 6 different Sentinel types, all focusing on different aspects of the environment. So 1 and 2 are more on land areas and ice and vegetation. Sentinel 3 is focusing much on ocean aspects. And then Sentinel 4 and 5 and 6 on meteorological aspects and characteristics of the Earth. So they're collecting a whole variety of environmental data and are doing that in the long term. So it's really a fleet of satellites to collect this data. And the definition of the Sentinels has been user-driven. So behind every Sentinel is a user demand for information that is needed either on a European level or even on a lower or global level. So it's also on different scales applicable. To give you only an impression on the different satellites, I put up the next slide that really shows how differently they are in their techniques to collect these different data. The white dots are standing for the ones that are already in orbit. And you see the principle that we always have several Sentinels that are prepared to really ensure that we have the data continuity, that we have the data available. There are always 2 Sentinels in orbit, so in case one of them is occurring some trouble, is getting out of duty, we still have the other one to collect data. And then we have the 3rd and the 4th that are already being prepared to be launched in case one Sentinel should drop out or is out of mission lifetime, which is of course also then after 7 or so years might be the case. Well, this is the hardware infrastructure behind Copernicus. All the data collected with the Sentinels is, of course, combined with other data that is collected in situ or via airplane or whatever, or even via social media. So also this dimension is evolving. And with all this data, we come up to the services. So you were already on the right slide. There are several services that are being produced on the European level, and the responsibility also of European agency to cover the different aspects of what is needed to be monitored, like land cover, land use change in Europe, in combination with either agricultural land use or also climate variations. So this is not only done on the European scale, but they're also collecting data on the global scale on vegetation and phenomena and changes in vegetation. And as well also with respect to the marine environment, with respect to the atmosphere, what kind of greenhouse gases or other gases are in the atmosphere, are concentrated in which areas, what are the changes over time. We have the climate change service that is running and providing also analysis of the trends and the shifts in the climate issues. And we have these more responsive and service of the emergency management, so that really steps in when a natural crisis, for example, takes place, a flood or a hurricane that hits areas and brings people in danger. So to help with data and help the people in place to bring the help to the people and build up the infrastructure. But this is only what is done on the European level. The benefits of the Copernicus program goes far beyond, and this is also only a snapshot, and it's already a little bit outdated. It's only to show there's a lot of in operation from the Sentinels and the services, but the data collected is freely open and available. So we have a lot of users already only on the ESA hubs that are providing the data, but there are also other platforms. As I said, the data is freely available, so it is included also in other platforms and is distributed worldwide in many dimensions, and is being used not only by public authorities, but also by scientists to better understand the world, and also by industry to improve their services and most often these are also subjects of efficient resource management where Earth observation comes in. So as I said, Copernicus is collecting global data, and this puts Earth observation in a perfect position to contribute also to the global agendas. And there are 3 that are really and the focus for us that are really urging us to get active. So there's the Paris Agreement on climate action and climate protection. There's the United Nations Sustainable Development Agenda and the Sendai Framework for Disaster Risk Reduction that are looking at global issues for our society and need the data on different scales, not only on the global scale, but this is also provided from the Copernicus program, but also to come back, what does it mean in the region? Where is where measurements necessary and what can be done, and to bring together the Earth observation data with the knowledge in the areas and with the other data to get a better picture and support politicians in taking the right measures. So Earth observation can provide geospatial data on different aspects, on phenomena like land use change, vegetation change. It can depict the evolution over time. So if we talk about deforestation, desertification, these are processes that can be monitored with Earth observation, as the frequency of the data is nowadays rather high, and then can build these time series of these processes. It can also help in sudden events, as mentioned, in case of disasters, or if there are burning events, whatever. And with this, Earth observation is, for our understanding, a good measure to help evaluate adopted measures by politics and also control how special areas are managed, if everything works well, if the measures turn out the way they were meant to turn out, and also to help in the building of scenarios and warning and giving prognosis to what might happen and to help mitigate potential effects. So this also, from our perspective as a German space agency, is is worthwhile to support it and to bring up new and beneficial applications to this domain. And among all the activities that we do in our applications program that really start with the missions and supporting the data quality and data ingestion and signal understanding, it goes much more further to really be user-oriented and to provide and help developing applications, services, and information products to support decision-making, to support the work in the fields, in the area, and to be beneficial in the processes that have to be managed. So we were very happy about the suggestion of the CoExist project, including the IOM as one of the users to such a project, to really give feedback on what is needed as information from the Earth observation data and have the stakeholders at the table right from the beginning to come up with hopefully beneficial Earth observation based information to support the understanding of the transhumance processes and also their help hopefully to mitigate conflicts. So we were happy about the proposal of the project. We were happy that it turned out to work from our perspective very well, and thus I'm more than curious to hear more about the outcomes today and have this webinar. And with this, I want to finish my presentation and thank you for your attention.
Thank you very much, Godela, for presenting the role of the German Space Agency of DLR in collecting satellite data related to the environment, and for introducing us to the Copernicus project, which are all very exciting prospects for Earth observation systems. And I will now leave the floor to Yonas, who will be explaining how the CoExist project has participated in the monitoring of environmental conditions in the context of transhumance. Yonas, over to you.
Thank you very much, Ariel. Yeah, I have the pleasure to talk about, let's say, how we use the data that comes from the satellite capacities that Godela presented us in order to monitor the environmental conditions for transhumans in the CoExist project. Next, please. I mean, as Damio was already saying, that there are a lot of armed conflicts and potential population displacements going on in the Sahel. So the news or the medias are full of news of clashes, farmer-herders conflicts. But this is just the tip of the iceberg, what we see, because many conflicts are not reported in the media. So these conflicts are still on the rise. And I mean, it's all about, let's say, natural resources, because farmers and the seasonally migrating pastoralists are actually competing about the same natural resources. And this often results, let's say, first in severe conflicts and also with a long-term effect of forced displacement of communities. So with, let's say, a little bit more on the background, as we've heard from Damien as well, so the livestock farming strongly contributes to the Sahelian states' GDP with up to 15%. And there's also kind of still some potential to increase this kind of productivity. I mean, they are seasonally migrating, the pastoralists, in search of water and pasture, but this is more and more challenging because they are usually following traditional corridors, but these are challenged through climate change, locally increasing population densities, for example, the introduction of new irrigation schemes with expanding agriculture or the intensification of land uses. So while actually the local farmers or this kind of type of agricultural system and transhumans complement each other traditionally pretty well, they are more and more competing about the same natural resources. So, and the peaceful coexistence of local farmers and migrating herders can be supported through providing, let's say, data-driven evidence about environmental factors that are the main drivers behind transhumans. This is just another map, let's say, just a broad overview map of the transhumance corridors. As Damios was saying, actually, these are just, let's say, very rough ideas. They are much more detailed. There are many more corridors, but it's generally, there's north-south movements, mainly depending on the season. And on the one hand side, there are the migrating pastoralists, which have always the question in their mind, can I use the traditional corridor? How's the situation in terms of environmental factors on these kind of corridors? How's the situation next month? When and where my cattle are facing risks? And all these kind of unknown factors are, let's say, following them along the path, mainly southwards. And on the other hand, there are the local farmers. They are, of course, caring about the food security of their families and having the question, how can I protect my crops from passing herds, for example? And for example, why don't they move elsewhere? So kind of there are some kind of competing interests or potential conflicts, as heard earlier. So this was the reason why we formulated different objectives of the CoExist project together with our colleagues from IOM. So the first idea was all these environmental factors can be well observed from Earth observation data. So we try to exploit that kind of data for an assessment of the spatial temporal dynamics of mainly the environmental parameters that influence transhumance patterns. So why are people going where? We tried to have a holistic consideration of various drivers. So we would like to dig more into the spatial domain of transhumans. The, let's say, outcome which we aimed for in CoExist should be an intelligent and repeatable model for transhuman suitability, because we had a study area in Chad, mainly it was a large study area in the southern part of Chad and northern part of Central African Republic, so a trans-border, typical trans-border transhumans area. But the model should be available elsewhere or repeatable elsewhere. That was a very kind of requirement from the very beginning. And the results should be being used in conflict prevention to help identify potential conflict zones and periods, and also to better prioritize the interventions in direct support of IOM's activities in the region. This is just an overview of the main satellite capacities we were making use of in the CoExist project. As Godela was saying, mainly the Sentinels, Sentinel-1 and Sentinel-2 data gives us a really incredible view of the Earth surface and the environmental conditions. So, for example, while Sentinel-2 is an optical system providing up to every 5 days an image of the Earth surface, it allows us to assess, let's say, things like vegetation condition on a regular basis. Sentinel-1 was mainly used for assessing surface water and its dynamics, which is also a very important driver for transhumans, because they need not only pasture, they need also water for the watering of the livestock. But also, let's say, the capacities from US missions like Landsat or MODIS are also giving us the, let's say, different aspects of environmental conditions, which we were monitoring in the project. And with using all these different data, we applied different kind of information techniques to derive the information we need on the environmental factors that drive transhumance. So we derived, for example, drought probability. We created a product, farming systems, which gives us really kind of a very spatial, detailed view on agricultural activities in terms of where's the agriculture that is irrigated or agriculture that is rain-fed. So at 10-meter spatial resolution, for example. Then we used the typical land cover data set from Copernicus. We used the population density data set derived from Earth observation data. We created a surface water dynamics product so that we have a monthly, let's say, a monthly data set that provides us the spatial location of surface water. We derived the rangeland productivity, which is also a main driver in terms of the productivity of pasture for the cattle, rainfall data, and as well burned areas, because burned areas are also kind of very extensive in the dry season in these areas, which then are, of course, areas of non-favorable conditions for transhumans, because there's no vegetation left, mainly as, let's say, potential pasture locations for the cattle. So with all these different environmental variables, we monitored a large area. This is just a map as an example, the farming systems. So we created for the large study area a 10-meter map of the rain-fed and irrigated cropland extent. It's important to say that we were trying to make use of only existing data sets or methodologies that exist that we can apply. In this case, for example, we used a methodology that we developed earlier, which was also published to derive the farming systems. Just the next example is, for example, we used the burned areas, let's say, on a monthly basis, because this is also a very important factor which can drive locally where the herders move. So monthly, the data set on the burned areas for the whole area. And another example, last but not least, just the land cover, which we used from Copernicus. But there are, as mentioned, many more. And how we use that different environmental factors, some on a monthly basis, some on annual basis, to set up a model to assess the environmental suitability of transhumans, that will be explained by my colleague Max. So happy to hear from you, Max, how we created the model. So over to you. Thank you very much.
Hello to everybody. Thanks, Jonas. So as Jonas said, I will tell you about the mapping of the environmental suitability for transhumans and how everything works together from the transhumans tracking tool data, conflict location data, and the Earth observation data. And As a first step, so next slide, please. Thanks. As a first step, we try to visualize the data from the transhumance tracking tool that was explained earlier by Damien on a map. So the transhumance tracking tool gathers a lot of information about socioeconomic parameters, but also information about the origin and destination areas of the pastoralists. And you can see here's a few red points, which are the survey locations. So the survey locations are measured by GPS devices. And here you can see the survey locations from 2018 to 2020. And then we also have some information about the origin and destination areas through the transhumance tracking tool, but we only have the names of villages, departments, or provinces, which means that we have to use Google Maps to search for village names and then locate these villages on the maps. This leads to small spatial inaccuracies in the locations of these origin and destination areas, as you can see in green and yellow here, but it's still accurate enough to be used for this analysis. And the shape of the study area that you can see in light blue here is quite special in this case, but we try to have it as small as possible to minimize the amount of satellite data that we need later on for the analysis. And in the next step, we calculated linear connections between origin and survey locations, where the thickness of the lines represent the number of participants per these linear routes, let's say, over the time span from 2018 to 2020. We did this to get a spatial overview of the data from the transhumance tracking tool and also to identify some prominent routes. And as you can see here now, we also did these linear connections between the survey points and the destination areas. Here it's important that you can see that the destination locations are mostly prominent in the southern part of the study area, which also shows the north to south movement during the dry season to find enough natural resources or fodder for the animals. So the TTT data in general provides a lot of important information about transhumance, but spatial information about natural resources and the situation along the routes is still mainly unknown. And therefore, we developed a spatial multi-criteria model that uses up-to-date satellite data that indicates the most important environmental conditions that are the drivers of transhumance routes. And these various environmental parameters that Yonas explained before, you can see them on the left. They were considered as suitability layers. And these suitabilities are monthly rangeland productivity, which was used as an indicator for the availability of green vegetation. Then we have the monthly vegetation cover as an indicator for the total amount of vegetation. That also includes the dry vegetation. We have monthly burned areas that indicate low suitable areas due to missing vegetation as grazing areas. Forest type represents two classes, the open and closed forest, where open forest stands for favorable areas for transhumance in contrast to closed forests. We also have used the distance to urban areas and therefore used urban areas as points of interest regarding animal markets, veterinary stations, or wells, for example. And finally, we used also distance to water bodies. And each of these layers has value ranges between 0 and 1, where 1 means highly suitable. And the spatial model calculates the mean suitability for all of these 6 input layers to produce monthly environmental suitability maps for transhumance. And layer weighting can also be integrated with local expert knowledge. And then on the middle, you can see the so-called mask layers. One slide back, please. Yeah, thank you. That were also considered in the analysis as areas that are not suitable at all for herds. For example, farming systems, which is cropland classified into rain-fed and irrigated fields, urban areas itself, permanent water bodies such as big rivers, lakes or reservoirs, and protected areas with access restriction. These areas are then masked out for the analysis of the environmental suitability for transhumance. And this whole analysis was conducted for the year 2019 as an example year, when we had the full data availability through satellite data, the transhumance tracking tool, and ACLED conflict data. One slide back, please, again. And the spatial model is totally based on free open source data. So we use different sensors from satellites from the European Space Agency, as well as different ready-to-use open source data products to produce all these parameters or layers that are needed for the spatial model. In total, we processed over 18,000 satellite scenes that add up to about 10 terabytes of raw data. So the model results are monthly environmental suitability maps for transhumance, whereby areas with a high environmental suitability for pastoralists reflect areas with a high abundance of natural resources, such as grazing land, water, and the required infrastructure. And then on the right, you can see that we also used additional data to add thematic context to the suitability maps. Which was the data from the transhumance tracking tool. It was used to verify high and low suitable areas during the wet and dry season, but was also used as start and end points for an additional spatial model to calculate the optimal movement paths. And then finally, we used the conflict data from the ACLED conflict database, and we used that to spatially analyze conflicts together with the environmental suitability and data on transhuman movements. So now I want to show you the first results on the next slide, where you can see the large-scale monitoring of seasonal pattern of environmental suitability for transhumance in the study area at a high resolution of up to 10 meters on a monthly basis. That is what you can see on the left. So these maps show the high spatio-temporal variability of environmental suitability for transhumance. And there it can be expected that the blue areas, which indicate low suitability in the respective months, are avoided as overlay areas for the herds, for example, due to missing natural resources, while red areas indicate good conditions. And you can also see that these high suitability values in orange and red shift towards the north of the study area during the wet season in the summer months, whereas low suitable areas are dominant in this area during the dry season. And besides the seasonal variability, there are some patterns of good suitability indicated throughout the year during the study area, which would theoretically be optimal for transhumance corridors. One slide back, please. So on the right, you can see a diagram where we used over 650 origin and destination locations from the transhumance tracking tool that were compared to the suitability values for these locations for each month in 2019. And you can also see the precipitation data in gray bars. What can be seen is that we have an overall higher suitability during the wet season, as well as an overall higher suitability in the destination area throughout the year, which is also indicated in these maps. As you can see in the southern part, where we have the destination areas, we have a higher suitability throughout the whole year. And the most important point of this diagram is that we have a higher suitability in the destination areas during the dry season, which explains the north-south movement by pastoralists. So this analysis proves the plausibility of the suitability maps as the main driver for movements towards areas with higher suitability can be seen. And now I want to show you the context of the environmental suitability and farmer-herder conflicts for the situation of December 2019 as an example. Here we overlaid protected areas into categories. First, enclosed protected areas, the dashed areas, areas that have access restriction, and then other protected areas in black boundaries that the herders can still access. We also displayed cropland in rain-fed cropland and irrigated cropland in dark and light green, and also conflicts for the year 2019 as red points. And as you can see, there's a massive agricultural belt that stretches from east to west through the middle of the study area and kind of acts like a spatial border for the north-south transhumance movements. And as you can also see, most of the conflicts appear near agricultural areas, which shows the necessity to mitigate the farmer-herder conflicts in these high-risk areas. What also is important, as Yonas mentioned before, the ACLED conflict database only shows conflicts that make it to the local or national news. And additional to that, the farmer-herder conflict suffers from poor reporting. So only a small fraction of the total amount of the farmer-herder conflict is shown on this map. Nevertheless, this analysis demonstrates the potential of this spatial model to support decision-making in regard to planning of prevention measures through identifying high-risk areas. And on top of these environmental suitability maps, we produced or developed another spatial model on the next slide that produces theoretical optimal movement paths for transhumance along the highest suitability values. So these paths are avoiding high conflict risk areas such as cropland and are navigating along those areas which provide enough natural resources for the herds. And so this map shows that there are only a few narrow corridors for herders to navigate through this extensive cropland belt, while these paths do not reflect real movement paths. They can be used for decision support, for example, on the spatial location of corridors for transhumance, as well as agreed passing times, which is one important conflict prevention measure, but it can be also used to regulate the agricultural extension. So finally, I want to just give you a quick summary and a quick outlook of the analysis of the CoExist project. So these environmental suitability maps indicate favorable areas for transhumance, but also high-risk areas for conflicts with local subsistence farmers. So they help to understand and manage the seasonal movement patterns to provide enough resources for pastoralists. The model itself is spatially transferable to other regions through its flexibility. So you can add new information layers, you can incorporate layer weightings through local experts, and in total, it helps in the understanding of the transhumance. Even though the exact migration routes cannot be determined, it still helps as a tool for negotiations with of transhumance corridors with local, regional, and national authorities. And it can be used as a possible planning tool with local experts for transhumance, but also for agricultural extensions. And it shows that we have new options for herders. It can indicate low-risk areas with a high abundance of main natural resources to support the pastoralists. And before closing this presentation, I wanted to point out our scientific publication from this year on the next slide that we conducted together with the IOM and the DLR. And in this publication, you can find everything that I explained now in more detail. And I guess you can find the link also in the chat after the presentation. Thank you for the attention.
you very much, Yonas and Maxi, for introducing us to the CoExist project, as well as the suitability maps and the environmental conditions maps that were produced through this project. Thank you very much. That was very interesting. And I will now give the floor to Anne-Catherine Schäfer to discuss the implications in terms of policy and programs of Earth observation systems, as well as other technologies to producing environmental factors data. Anne, over to you.
Thanks a lot. Good morning, everyone. So I'm coming to you today from Chad. And I mean, as you can all see, probably from the presentations that were just done, I mean, this entire coordination and this joint analysis between IOM, RSS, and DLR has been very, very interesting and quite fascinating for all of us, because it opens up the possibility of really redefining how we're looking at transhumance and how we're looking at mobility and migration patterns from a much more holistic and scientifically based approach. And this has been really interesting for us specifically here in the center of Africa, because we're at the crossroads of quite a number of different transhumance routes. The data that has been looked at specifically, thank you for putting up the slide, is really looking at the yeah, you can go to the next slide, thanks. Is really looking at the borders between Chad and the Central African Republic, but of course Chad bordering the Lake Chad Basin, bordering Libya, bordering the Sahel, and bordering Sudan, has a lot of different implications on transhumance. And so just from a very programmatic perspective, for anyone who has not read the 2012 publication Transhumance en Centrafrique that was published by the International Crisis Group, I can really only recommend doing so, because it gives a lot of really good insight into the mobility patterns and the conflict dimensions of transhumance, and has been kind of the standard document that we have all been working with that are working on transhumance here in the country. If you could just go to the next slide. This is the map that was produced by ICG, and in 2018, this is where we started from. So this is the kind of data that we had available in 2018 when we first started looking into transhumance here in country. And as you can, of course, already see after the presentation that was just done, this is very simplified, even though it was very detailed at the time, but it didn't give us a lot of input into how we should really approach transhumance management from a very policy and from a very pragmatic lens to actually work on human mobility specifically. If you can go to the next slide, please. If you put the two ideas right next to each other, you will already see that this has really changed our way of looking at transhumance in Chad and between Chad and the Central African Republic. And the very important point, if you overlap now where the red dots are, which indicate where conflicts that made it to international news have occurred in the last couple years and where the transhumance corridors actually run, you will see that there is quite a disconnect. And this was really important for us because for a really long time, we were all under the impression that the most important thing that we need to work on is the transhumance corridors and the water points, that this is where the conflicts happen and that the conflicts happen in and along those transhumance corridors. It turns out that that is not quite correct. If you do overlap the timelines of conflicts with access of transhumance to agricultural land or to grazing fields, it actually turns out that the main issue of the conflicts occurring are overlap with markets. So meaning that if there is a high concentration of cattle or livestock in a certain area because people are accessing certain markets at certain times, then conflicts occur, and much less because people are moving along corridors that are poorly demarcated or where there is poor access to water, or where water access overlaps with the water access for farming communities that are living in the same area. And that has been really a quite revolutionary discovery because it means that we need to look at management of transhumance from a completely different angle than we had anticipated, which means much less on demarcation of corridors as opposed to access to markets. And that really changes a lot on how we need to work on transhumance management, not only with communities and provincial government, but also cross-border. I think there was a question already now in the chat about health implications, and Damia mentioned it before during the COVID lockdown, how mobile communities were locked down in Mali, Niger specifically, because that's where they were at the point of time when the borders closed. This makes a huge difference to the way that we need to look at how programs need to function, and programs need to support provincial government, transhumance communities, and farming communities, but also intergovernmental agreements on the movement of transhumance. Because if markets are really the draw point and the conflict point, and it is at those intersection of concentration of cattle and livestock in a certain area that we're seeing a spike in conflict and a spike in violent occurrences, that then this means that we need to redefine how we're going to programmatically respond. Of course, these kind of events then also, especially like now in times of COVID, where we have a high concentration of people coming to a certain area, also means that this can be potential spreader events. So there is a lot of overlap of different information, especially when mobile population then moves on and can act potentially as a vector for potential health threats to other communities. So this is something that we as IOM have been looking at quite carefully, because we are also looking at such events together with FAO, for example, on livestock health, livestock vaccination programs, but also provision of identity cards to mobile communities that are moving along the transhumance corridors. And there is a lot of replicability of this specific model beyond this rather small section that we have looked at. For example, for the last 5 years, IOM across the entire Sahel has collected a lot of data on population movements, including transhumance, but well beyond. That with this kind of analysis and partnership between new partners, I would say, there is a lot of potential for looking into opportunities for programming in the wider Sahel and beyond that link climate change, transhumance, conflict patterns, forced migration patterns, displacement patterns, back into very real opportunities for programming that is based on actual over time analysis of data. And that is something that has been quite new, because this kind of data has previously not existed, not been available for policymakers or for programmatic strategic development of any kind of programs. So for us, this is going forward, this is going to be really interesting, and I think it's going to be really important to continue working on this partnership as well. And I hope really that this is going to be data that's going to be available and used by a lot of partners that are working on these questions, because we really need to find new ways of dealing with transhumance that goes well beyond demarcation of corridors and water points, as it has been clearly shown that the factors that are leading to conflict go well beyond these two issues. And while this may have been just a snapshot, because that's where the data was available, it is certainly replicable across Chad and well beyond into the Sahel. Thank you.
Thank you very much, Anne, for explaining how data from the CoExist project has helped redefine priorities in terms of policy and programs related to transhumance management. It's very interesting to see how data can help orient and guide policies and programs related to transhumance. So this brings an end to the presentation. I would like to thank once again all panel members for introducing us to the CoExist project and for presenting the different tools and the different data that came out of the CoExist project, and for introducing the Earth observation systems and the use of Earth observation systems data for transhumance management and the prevention of conflicts related to transhumance. We can now move on to the Q&A session. So if anyone has any questions that they would like to say orally, you feel free to raise your hand on Teams, and we can give you the floor. But I see there are a few questions on in the chat. So Anne already partially answered to one of the questions on health applications, but I will repeat the question, which is from, and I apologize in advance if I mispronunciate anyone's name, but it's a question from Trish Schwertle on health application of the tools. So Trish asks how these tools can be linked to health systems as people move. And she wonders whether there are any ambitions to use these tools to support health goals such as universal health care, pandemic and emergency preparedness, and so on. So as Anne already explained, the TTT was already used to better understand how transhuman herders were stranded during the COVID-19 pandemic, and how the data collected can be used to identify potential super spreader events in the case of pandemics. But I would also maybe like to give the floor to Damien and then Godela to maybe explain how the transhumance tracking tool, as well as how the Copernicus project and other projects funded by the German Space Agency can help, if they can help, and how they can help to support health goals as asked by Trish. So Damien, first over to you, and then we can move on to Godela.
Yeah, I think the TTT can, I think, pretty much like what Anna said already, it would allow us to know a little bit better where big movements are happening, which then potentially, yeah, of course, is linked with also some health issues. So having especially a look at the flows would lead to having a better idea of potentially where some health issues could rise. This is something we could actually look at. It's quite interesting, and especially with animals, we could also look at the veterinarian issues. I think there is potential. It would mean quite a lot of research, but that's definitely something we can look at. We can also quite easily do surveys on those herders that are moving across borders, and that would also probably hold some questions on the health that we could analyze after. I don't know, either between Godela or Yonas, feel free to intervene on that point. I see that Yonas had his hand raised.
Yes, thank you very much, Damien. Yeah, Trish, good to have you here. We know each other from a project we have in Burkina. So the question of Trish, I guess, mainly aims at, let's say there's a lot of survey data collected in the transhumance tracking tool. And on the other hand, there's a lot of data collected by the health surveillance systems in the different countries and different regions. And I see here great potential to being linked anyhow. For example, either that, let's say, the health surveillance system are incorporating transhumance, but on the other hand, also that, for example, the transhumance tracking tool could, as part of their survey, also, let's say, incorporate the public health and health surveillance data in this way. So I definitely see here an overlap, because both surveillance systems are very time-consuming and intensive, and it would be a great opportunity to here and there kind of synergize a little bit the efforts. in this regard.
Thank you very much, Yonas. And Godela, could you maybe provide also, if there are any, of examples of projects funded by or supported by the DLR, which support health goals?
Well, actually, that's a good question. And there have been projects covering health issues, but not so many, I have to say. And actually, I think, Yonas, you were running also one of these projects considering health issues and vector diseases and the spread of vector diseases through analyzing the Earth observation data and the areas affected for their likeliness of what are the habitats like, where the vector animals the animals that are carrying the vector diseases. I have no knowledge actually whether there have been some real implementations of such applications. So there has been proven evidence that this data can be used, but as far as I know, I don't know of any concrete example where this data is really combined and then really put forward in a running application. But maybe I'm a little bit out of date there. I think that's still a very and you pointed out it's an issue that should be looked at, and if there's more potential from the Earth observation data to support these aspects, then the people who are working on it then should come together and sit down and bring their expertise together to come forward with maybe even better solutions. I think there has been not only an evolution furthermore with the Earth observation provided, but also with other data that can be included, and also the data management infrastructure that is available now. I think it's much easier to integrate it. Still, at the end, it really, it's in the details where you have to look at, but so I cannot really contribute something very concrete, precise, but I see the potential, and maybe Yonas, you can even add some more to this. I don't know.
I mean, yes, of course. Let's say everything that is related to environmental factors, there is kind of the opportunity to use Earth observation data. So, for example, as Godela mentioned, for example, in the domain of vector-borne diseases, like, for example, malaria, there's also some Earth observation projects that use Earth observation data to identify potential habitats for the vector. But also other, let's say, food security related projects where, for example, the agricultural productivity is estimated at a really kind of a small scale microfield level, where we can then support, for example, studies on, let's say, malnutrition, for example. So let's say Earth observation data is being used more and more in the public health domain, I would say. Ariel, over to you.
Seems to be having some trouble. I've seen a few questions related to data sharing and map sharing on the TTT, on the transhumance tracking tool. I think that's something that can be fairly easily done, probably more on a request basis. So you would need to email us, I would say, for that specifically. But those are not data that we are hiding, so it would be fairly easy to share it with you. I wonder what's your point on this, Yonas, on your side? Like, how do you see potential sharing of this? So that's the first question. And then I also saw the question from Chiara on replicability and increase of scale. And I think that's interesting because we're also discussing that with Anna recently. How can we increase basically that area that you've been looking at to something even more massive? So 2 questions, and I think Yonas, it would be interesting to hear you on that.
Yes, I mean, generally, we are working with data that is globally available. So that's a good point, meaning that also the models or the methodologies can be let's say, transported to other areas or could be generally expanded. Of course, we are talking about terabytes and terabytes of data, which is less of an obstacle than it was 10 years ago because we have the IT capacities to analyze this kind of big data. But still, let's say when we would like to scale this kind of system up for example, for the whole Sahel, the question would be, do we need kind of 10-meter spatial resolution for the whole information, or could we decrease the spatial resolution, which would then allows us to be more efficient in terms of data processing? So yes, generally it is possible from a technical point of view, but of course it's always related to complex data analytics, which we then should kind of trying to simplify a little bit for the benefit of being more fast, more near real time and larger coverage.
Thanks for that, Yonas. There was a question also from Keys. Has there been any attempts to use satellite imageries to detect where the herds are currently located and how they are moving? I was wondering if, Anna, you would want to comment on that.
Yeah, sure, thanks. So actually, there have been a lot of very long discussions on this particular question, and ultimately there are a lot of ethical considerations that I think that need to be taken into account, much more so than the ability to use technology to do tracking of transhumance movements. For personal integrity questions of tracking the transhumance communities that are moving along with the cattle. And then as well, I mean, looking at the ICG report specifically, I mean, given this neo-transhumance movement development, if you will, that is much more transhumance on an industrial scale as opposed to traditional transhumance that is moving historically through the region. There are a lot of considerations also in regards to security. And these kind of movements specifically between Chad and the Central African Republic that need to be taken into account, which make it very, very ethically very problematic to do this kind of observation. And I realize that in this specific context that we're discussing today, where we're really looking at the technology that enables us to overlap the kind of data that is available. These kind of considerations on the ethical use of data, the security of the individuals that are moving along with the transhumance movements, especially historic nomadic movements, as opposed to, let's say, industrial neo-transhumance, really need to be taken into account, specifically when looking into the detection of where herds are, because, I mean, there are people moving with them, and not all the transhumance movements, specifically in the Central African region, are necessarily only historic movements anymore. And a lot of them are very much heavy investments and heavily guarded investments of individuals that are, well, using cattle and livestock and the movements that they go with them as an investment tool. So I think that there we're getting into a very complicated ethical kind of question that needs to be very carefully considered when talking about how to track movements in real time and who that data then is shared with and who has access to it. It's really interesting because in Sakuma National Park, for those of you who are following this, there is a very similar satellite tracking that is ongoing of the elephant herds that are there for the very same reason. It's for protection reasons, but that data is most certainly not internationally available and cannot be accessed for the very same reason. And because there is such a value to obviously the protection of Africa's largest wild elephant herd. So I think we need to be really mindful about the type of movement and the type of tracking that we're doing and how that data is shared and available. So maybe just as an ethical consideration to that particular question. Thanks.
Really well put. I so sorry that Keith actually had raised his hand. Do you want to comment on that?
Just for a brief introduction, I'm Kees van Nijvenbeek. I work with the Netherlands Space Office on the G4AW program. We have relatively similar programs in Mali, Burkina, and now also in Niger, where we help pastoralists to find the fresh biomass and water. But we create like now a private sector-led initiative based on an operational product. So farmers actually use a tool to find the roots. And I haven't really heard a link, or I missed it with the operational delivery. Is this resulting in a product that can be used by the farmers themselves, or is it at a higher level to monitor what's going on?
Thanks, Keith. Yonas, do you want to comment? On my side, what I would say is it's true that for the moment it's probably more at the policy or programmatic level that we're intended to act. The fact that at least on the transhumance tracking tool side, we work directly with the Réseau Bilital Marobé, does help kind of linking back a bit more with the communities. And so the TTT itself is very much a tool that is being implemented and then used for the herders community and for the municipalities to kind of handle and minimize as much as possible conflict or prevent. So on that side, especially on the early warning system side, the idea is very much on that front. On the other side, on the CoExist itself and the use of Earth observation, it would be interesting to hear from Yonas maybe on is there a way to actually work a bit more directly with the herders communities?
Yes, I mean, thank you very much, Keith, for the question. Of course, let's say there are information transmission technologies which also the herders could benefit from. In this stage of the project, let's say we first developed kind of this multi-criteria model using Earth observation data to derive the environmental factors that comes together to these suitability maps in order to, first of all, get a better understanding of, let's say, potential conflict hotspot zones to better understand the transhumance patterns. But of course, this would be, I would come later to the outlook, one of the next steps, so that we not only use this kind of information operationally in terms of, let's say, conflict prevention, but also kind of to, let's say, allow the herders to benefit from the data in terms of increase their productivity of this kind of agricultural system to kind of guide them. Of course, that would be one of the next system, which was not part of this recent project.
Thanks, Jonas. Sorry, I don't know if Ariel, you want to continue or
Sure.
Go ahead.
Yeah, there's a very interesting question by Patrick Buca, who asked whether the finding which you presented on the link between access to markets and conflicts and it's the closer link between access to markets and conflict than access to water and conflict has already been leveraged by policymakers, and that is actually linked to a question that I had personally on whether these the findings and the results from the project have already informed or have already guided policies related to transhumance management in the region. And as Patrick asked, are there signs that policies for the peaceful management of transhumance and coexistence of herders and farmers, are there signs that these findings are being used by policymakers to inform transhumance management policies? Are these findings being used?
I can maybe leave the floor to Anna on this and come in after.
Thanks. So yeah, that's a very interesting question. I think, I mean, one, we need to all remember that policy always takes a really long time. We've been very vocal on these findings. I mean, obviously it's relatively new. Obviously, we're presenting it today for the first time, and the report only came out quite recently. And it's, I mean, also for us on the programmatic side, it was quite a study to go through the documents and come to these realizations. So one thing that, I mean, for those of you who don't know, I mean, IOM is a purely projectized organization. So for us to programmatically respond to any kind of findings always requires that there's donors who are going to be realizing those kind of realizations with us. And that, of course, always takes a certain moment, especially right now, as the entire world has shifted their attention on a quite different world region, which is rather problematic because food security, especially in the Sahel, is really suffering in consequence. But that said, there are a number of undertakings right now to try to react exactly to this very finding. From different angles. We're trying to address it from different angles. One, through the human mobility dimension, by trying to look into how can market access and transhumance coexist in a way that conflict mitigating measures are being put in place from the onset. That is a really interesting question, because usually those actors that are specifically working, and those ministries or national actors that are working on market access and market functioning, are really quite different from the ones that are working on transhumance. So bringing them all together is really is a bit of a challenge. It's something that, I mean, again, it's all a pilot phase because these findings are new. So we're only just starting this work now. So this is going to be really interesting going forward to see where this is going to get us. We have just restarted TTT work in southern Chad, where we're going to continue looking into this very phenomenon. What is going to be really interesting as well is that because of climate change, because of COVID, because of the security in the region, border crossing, market access, and the dynamics and the political dynamics in the Central African Republic, in Libya, in Chad, are so unique right now. I mean, everyone who's been following the dynamics in the Central African region, I mean, you know that we're in a political transition in Chad. There has been a very challenging election in the Central African Republic, and the situation in Libya, of course, is complex in its own right. So market access, specifically cross borders, and specifically for transhumance that rely on international market access, across borders, has always been a particularly complex topic that is really difficult for all of us to address jointly. And now they're overlapping this, and this concentration of cattle in the vicinity of these markets, of these marketplaces, or when they are moving onto these marketplaces, and there's a higher concentration than usual of livestock moving towards those marketplaces. If that then overlaps with borders being closed and the transhumance not being able to move on from one market to another, it becomes very complicated and requires a very high number of stakeholders to be brought together to look in this very specific topic. So this is being more and more recognized as a challenge, and is definitely something that is going to hopefully inform transhumance policy in the future. There is supposed to be a summit that is going to be coming up in N'Djamena, which I hope is going to also look into this. I mean, we're lobbying really hard for that, and we're really hoping that the kind of data that was produced here through this analysis is going to be part of the background information, if not part of the live discussions, because it is going to be really necessary for this to be considered going forward. However, the mills do grind very slowly, and I think coming up with these kind of findings with this level of scientific data is going to take a moment to be put into policy action, that then is going to result in active programs that can support these findings, since this is really all quite new. But yes, we're working on it to the best of our ability. Over to Damian.
Thanks. I would add also that one of the big things that is at stake also is to kind of understand in terms of quantity, the number of animals and the number of herders that could move in. And I think combining TTT and the Earth observations is a good way to start getting a better idea of those quantities, which is part always of the negotiations between West and Central African states every season on the number of animals and herders they would let in, especially to the coastal countries. So I think it's also quite important to look at that aspect of the quantification, because it's always part from a policymaker point of view of the negotiation. So if this can shed light a bit on that, it's useful. It has been used quite a lot during the kind of the heart of the COVID situation the last couple of years to advocate a little bit more with a few of the coastal countries for a bit more openness of the borders. But I think it's also, as Anna is saying, a fairly recent project, and we still need to really take the start working very much with policymakers on that to make sure it's being used.
Thanks a lot, panel members, for your answers to the questions, and thank you very much to attendees for these very intriguing and interesting questions. One final question that I would have would relate to the future and the outlook of Earth observation systems and the new technologies and the new tools that were presented during this webinar in terms of decision making and informing policies and programs relating to transhumance. And this gives me an excellent segue to move on to the final section, which will be closing remarks and outlook, which will be presented by RSS colleagues. So Yonas or Maxi, over to you for the closing remarks and outlook of Earth observation systems.
Yeah, thank you very much, Ariel, for, let's say, drafting this major questions. Of course, we are also interested in seeing kind of a roadmap, how we go on with the developments we have now for towards maybe an operational system in a way. So a little bit of an outlook here. So our question is, first, now we have developed kind of a flexible model using the different Earth observation derived environmental factors that we can put together in a way as it wasn't done before. So because we are looking at a wide range of different environmental parameters. But the question is how to improve the developed concept further. So we were also talking about, let's say, being spatially more explicit in a way that, for example, herders could be kind of tracked via GPS devices, for example. In this regard, I must say that we actually have foreseen a parallel project with CoExist, where we are working with a research institution. They have a device on the ISS, the International Space Station, which allows them to really live track wild animals that are collared with GPS devices. So they are doing that kind of in terms of mainly wild animal tracking, but we have planned that project together with them, for example, to also trying, for example, GPS collars of some cattle, to just really kind of have a very spatially explicit path along their ways. Of course, Anna raised the issue of ethical and data security issues. Of course, this is a major thing we have to turn our heads around. But I guess there are international protocols in terms of ethical considerations in this regard, which could be solved. So this parallel project couldn't take place because of technical issues, but I hope that in the future, let's say, any kind of technology could be used, such as participatory mapping or regular phone checks for location tracking, that would help particularly the transhumance management to be more spatially explicit, because we really don't know where they move when. And this might be a very interesting topic. We would also like to investigate to improve our developed concept. So another question was now, of course, how to implement the monitoring framework that was here developed. So the first step is the showcasing of the potential of this monitoring for targeting and prioritizing conflict prevention activities, and that's what we are doing with the CoExist project. This is what we are doing here with this webinar. But this kind of showcasing of this potential must go on. So we need to stimulate the use of Earth observation data and about kind of spatial data in the humanitarian sector, meaning that this kind of can then be transformed from this conceptual monitoring framework into operational practices, and which would help here that we have more pilot projects in the future where we are really trying to use that concept that has been developed in CoExist to put into operational practice. That would be really, really interesting, not only for the transhumance management support, but also, as discussed earlier, or the question was raised by Keith, to see how the farmers and, let's say, the pastoralists could benefit from. So we might even need to really break this very complex environmental information down to very simple information for the herders, for example. Like, for example, 2 days walking distance east of you is a really good pasture for us. It's something very simple things, and how we can, let's say, translate that complex information into very simple decision support to also increase the productivity of this agricultural system. So, and the last step, really the long-term goal, would be kind of to institutionalize the use of Earth observation and to establish kind of an early warning system for the transhumant management mainly, that can be definitely near real-time linked with up-to-date conflict data. So this would be kind of the outlook. I think we are here at a point where we can really have a really good idea how this different data-driven approaches can be put together to develop ideas for pilot projects and further develop these early warning systems. But this, of course, needs further, let's say, activities and endeavors, which we are definitely open to discuss with any one of you who has ideas to develop together ideas on such kind of pilot projects. So, yeah, showcasing, transforming the concept into operational practice, and then to institutionalize. That would be the long way to go for making really use of this kind of beneficial technologies, which we see here. Just as a last slide, for example, we also developed a prototype web map application where we allow the public to use this kind of data. So it's interactively, you can browse through the different months, which we considered in 2019 in Chad and Northern African Republic. So you can really interact with the data, and you see up to the full spatial resolution of 10 meters to dig into the data. And this kind of could be a platform, at least for the transhumance management, that could be enriched with TTT data, other conflict data in the future. This is just a rough first prototype, but this should give you an idea how this could be lead to a kind of spatial decision support through Earth observation data in this kind of domain. So from my side, I would really like, first of all, to thank, of course, IOM for the cooperation in the CoExist project. It was really kind of inspiring us to develop new approaches using Earth observation data for your support. And I was really surprised by your high motivation to making use of this. So this was very inspiring, and thank you very much for the great cooperation. I would also thank the DLR, the German Space Agency, for funding, also the Federal Ministry for Economic Affairs and Climate Action. Just with this funding, the CoExist project could be realized. And yes, I hope together we can go into the future with new ideas and really kind of bring that or push that kind of approaches forward. Of course, thank you very much to all participants for your interest in this topic, for the interest of these kind of developments we have done in the CoExist project. As mentioned, there's a paper available which details all the technical details if you are interested in. Please contact us if you have questions. So many thanks for joining today in this webinar. Also, I mean, Ariel, for guiding us through. Many thanks for your efforts to put that webinar together. Final words over to you, Ariel. Thank you very much.
Thank you, Yonas, for your closing remarks and for your last words. So this brings an end to this webinar. I would like to give heartfelt thanks to panel members, to Damien, Godela, Yonas, Maxi, and Anne for their very exciting presentations and for presenting the CoExist project and for introducing us to Earth observation systems and how satellite data and these new exciting tools and methodologies may produce environmental related data and deepen understanding of environmental conditions to guarantee and to further peaceful management of peaceful transhumance and coexistence between herders and farmers, and hopefully prevent conflict, agro-pastoralist conflicts, as well as increased productivity related to transhumance in the future. So I'd like to thank everyone for participating and for attending this excellent webinar, this very exciting webinar, and I wish everyone a very nice end of the week. Goodbye, everyone, and thank you very much.
Bye, thank you.